Hello, my name is Daniel Solorio, and I will be talking to you about the topic 8. We know that electric fields only interact with other electric fields. The direction of the flow of the field can be determined by the charge of the particle. And if the electric field magnitude is big, then it means that there are many field lines passing through the box. For example, there are various examples of particles in a box. If there is a positive particle, then there will be lines coming outwards of the box. If there are two positive particles, there will be even more lines. And the same with negative particles, only that instead of the lines going outwards, the lines will be going inwards. And then when with one negative and one positive particle, there will be no electric field since they are yeah. And if there are no particles in the box, there is also no electric field. The example of the box is we know that there are electric fields passing through given surfaces, and those are electric flux. The electric flux is the electric field lines that are passing through a given area or surface. Now we will talk about Gauss's law. Used to calculate the electric field, it is an alternative to Coulomb's law. Law states that the total electric flux through any closed surface is equal to the total net electric charge enclosed by the surface divided by like an E is 0. Okay, so the problem states that we must find the electric field E at 0.02 meters from the surface of a sphere with radius 0.1 meters if it has superficial density charge at plus 8 nanocoulombs. Okay, so we know the data, which is the 0.02 meters from the surface, that's the distance. We also know the radius, which is 0.1 meters, and we also know the superficial density, which is 8 nanocoulombs. We have to find the electric field. So that formula tells us that if the distance is bigger than the radius, then we should use the first formula. But if the distance is smaller than the radius, we should use the second formula. In this case, the radius is bigger than the distance, so we should use the second formula, the one that says E is equal to 1 divided by 4p 4p times the E with the 0 times QR divided by R cubed. And we just substitute all the values into the formula. We continue using the formula, and then we get to the result. The result is 1438.03 newtons divided by coulombs. The electric field, which is what the problem is asking for.